So I'm going to talk about the issues around the design and implementation of an advanced metering infrastructure, purely based on our current trials that we are doing at the moment. The way I'm going to split this presentation, I'm going to give a brief overview of Thames Water for those who are not familiar with, our trials objectives and the technologies that we are using there, because we are testing two different technologies. Also the issues around the design and implementation of such trials, more details, specific details about those trials, and a brief summary. So, Thames Water is the UK's largest water and sewage company with 14 million customers. We have 100 water treatment works providing 2,600 million litres of tap water to 8.8 million customers, and 350 sewage treatment works providing treating 2,800 million litres of sewage to 14 million customers. So our trial, I will start with the objectives, why we are doing this. We want to have full DMAs metered, all connections metered in there, not specifically customers, but all connections. We want to evaluate two different technologies there that I'm going to mention later. We want to get frequent and near real-time meter readings with a high data granularity. And one of the key things is what we want to achieve with that is the water balance, where we are going to have an accurate and precise water balance detailing what is customer side leakage and what is network leakage, so we can understand, we can have an accurate picture of our network in that area. Also, with these trials, because we are collecting so much data, we will be able to understand the customer behavior through the seasons, the consumption patterns. Do they change? Why they change? We will be able to also see what are extra benefits from that with regards to how can we improve our customer services. Can we provide them more, or what more do they want that can improve that? Another very key objective for this trial is the targeting of mains replacement, because the company spends, it's very expensive to replace the mains, and we have this aging network. We have our models, we have some data that we built our models to identify the areas where the main should be in a bad condition, and also based on the leakage, that information that we have from that area, and then replace those mains. So now if we have a whole area with everything metered, we have an accurate water balance, we will be able to say that actually our network is not too bad. So the leakage is customer side leakage and not network. So this is one of the key things that we could find real benefits on that, and the investment for mains replacement. And along this trial, during the whole period, obviously we are going to have a cost-benefit, to investigate a cost-benefit analysis, where we are expecting a higher productivity on meter readings, we are expecting OPEX savings, and also CAPEX savings, because if we can compare with our models now that how we are targeting the mains replacement, and if this, installing intelligent meters everywhere, could help us to better target, so we might have some, we will have some CAPEX savings as well. So the technologies that we are using for this trial are basically two. We are using a conventional AMI and one that we call advanced AMI. So the conventional AMI that we are using is the Vensis home rider solution, where basically the meter sends the data, the meter reading and alarms, to a repeater and then to a concentrator, or directly to a concentrator depending on the location, on the range. So it's a perfectly standard fixed network. Now what we call advanced AMI is we are using the system by Archiva and sensors, which the meter doesn't need to communicate to a repeater or a concentrator. It communicates directly to an antenna using a long-range radio, so using a lower frequency for transmission. This system is the first in the UK to be used. It's widely used in the United States with 12 million endpoints, and on a monthly basis 370,000 being installed. We have done a previous trial with the system to prove the concept here, and the results indicated were really good. So now we are going to a larger scale trial to check these benefits. So, as we want to do this with full DMAs, with AMI, to design this, you have to think about lots of areas what could go wrong, because everything will go wrong anyway. First of all, you have to think about the type of technology you're going to use. So we are using two different ones, conventional and an advanced. The conventional, you know, you will need to locate, to install repeaters, install concentrators, lampposts, buildings. Is that easy? Is that difficult? You have to liaise with councils. Are they going to be open for that? Are they going to help us in that? Are they going to be, you know? So this is going to have a big impact. Also the installation, the areas that you choose to install this. What is the meter penetration there? Have an X amount, and those are the easiest one, where you're going just to replace your meter, that is the existing meter there, replace it with a new AMI solution. Or you're going to have several digs, or you have already meters there with, for example, loggers attached for customers, or even for us, for our network monitoring. So you're going to put an AMR. You still need the logger for other parts of the business, so you have to think about this, and you know the times that's going to take. The customers, currently Thames Water cannot simply compulsory meter everyone, so we don't have the powers for that. So we have to create a customer journey. How are we going to approach the customer and say, look, we are trying to look into this trial, into these technologies, the benefits are blah, blah, blah. How we do this communication with customers. Because we are going to say someone doesn't have a meter. Look, we are going to put a meter there, but we are not going to charge on that meter. Customer, you have to have a really good relationship with the customer, so you have to be clever enough. You have to get the communication guys to get on board and do this communication and explain to the customers. Liaison with council, so I mentioned already, you know, the issues depending on the technology you are using, also the disruption on the streets and so on. What are the implications of the IT processes and data analysis? So we are going to collect a huge amount of data. So as we mentioned, as someone mentioned before several times here today, so yeah, it's not good enough just to collect loads of data. We have to do something with that, and we have to be intelligent enough to process this data and make good use of it. So we have to bear that in mind, how you're going to deal with that. Another key issue is the data protection. So we cannot simply go to the customer and say, okay, now I'm going to read your water consumption every minute, every 5 minutes, every 15 minutes. Doesn't work like that. You have to have a justification for what are you doing with this data, how this data is going to be held, where is the data protection, and is the security of data as well. Is this data easy to be collected by someone else and things like that? So things you have to put a package together to cover yourself and say, look, this is what we are doing, this is how secure the data is going to be. And obviously the objectives and outputs expected. So why you want to do this trial? Is this just for meter reading? Is this for extra benefits? What do you expect? When do you expect that? So taking on board all of these issues that you are going to have designed in the trial, you cannot simply say, yeah, let's do this now, let's have results in 3 months. You know that things go wrong. You know there are several issues around it. So you have to bear that in mind, because your time scales are very important there. You cannot keep delaying things because, oh, now something extra happened I haven't planned for. So you have to bear all these issues when you design the trial. So a bit more details now about the trial. So we are running this trial for 2 years because one of the reasons we want to see the seasonal variation of consumption, what happened. And we are installing this AMI in 6 DMAs, 3 in London, 2 in Reading and 1 in Swindon. 2 in London and 1 in Swindon we will use the conventional AMI. 1 in London and 2 in Reading we will use the advanced AMI. Over the 6 DMAs, it's covering 6,500 customers, but as I mentioned before, we are not metering specifically customers, but we are interested in the connections because we want to have a tight network, a tight DMA, where we know where the water is going. The reason for that, one of the reasons is we don't have compulsory metering power, so you have, for example, a block of flats would be so much difficult for us to go there, let's say they are not on a meter, and say, oh, we are going to meter you now. We cannot do that, and also, the costs will creep up. And in this situation, for example, in flats, we're installing a bulk meter. So we are guaranteeing that the connection, at least, is metered. All these DMAs, the meter size range varies from 15 to 100 mil, that we are replacing all of them. The readings we are going to collect, the frequency is going to be 15 minutes data. We are going to get 15 minutes data from loads of meters, so we need to process this information. The solution we found was with Takadu to use their system to process this information. The next slide I'll talk a little bit more about that. And we want to have a near real-time water balance. We decided we're collecting this 15 minutes data, but actually the transmission of data to our service is going to be every 4 hours. So that's why the near real time. So currently what is it's going to happen, Vences and HomeRider, they will send the data format that we requested to, they will get the readings and send to their own servers. Archiva and Census will collect the readings, go to their servers. They will then transform this data in the format that we ask for, what we want all the fields, because they have different data they collect, different data. But because we are collecting 15 minutes data, as long as we have the meter readings, we can calculate how much is our leakage and etc. Although we are also collecting their own alarms for leakage as well. But we have like temper alarm, battery alarm alerts, and also any other alarms they have. So this data is then sent every 4 hours to our server, where then Takadu will collect this data from our server every 4 hours, and they will process that. So they will get the alarms, for example, they will analyze, for are we missing readings? There are some gaps in the data. Is there a problem with any of the radio transmitters? So, we are going to have alarms sent to us and say, look, this is the problem, these are the problems. Also, we are going to have then our water balance online that is going to be accessible by a web interface, where we are going to be able to get DMAs or even zoom into street level and get all the information, because Takadu will also collect not only these AMR readings, but also, obviously the DMA meters. So they will be able to do the water balance, and we will be able to export the data to provide this to other parts of the business where we do our modeling and consumption and etc. So what are we going to evaluate now? I split this presentation in 2 parts. One is the technical evaluation. We are obviously evaluating 2 different technologies. We want to see what is the reading accuracy, what is the reading frequency, gaps in the data. Is the system reliable? Is the data always available as we requested? We want data every 4 hours, and we want the full data there. What is the rate of equipment failure? What is the vulnerability of the equipment? Here, for example, you can already see something could go wrong with the conventional AMI, because you have repeaters outside. Could someone just not gone off? And what happens to the data? Are we going to miss the data? Is the equipment able to hold that data? What is the flexibility of the system? How can we use this? Can we use this system for something else apart from the meter readings and other monitoring? We are going to evaluate also all the process involved to get all this information. What are then the additional benefits of the technology being used? Can we plug into other remote control of pumps, for example? What is the data security, if there is any issues around data security in each system? And the other bit that we are analyzing is the data, which, as I mentioned before, we are going to have detailed water balance with daily consumption, night use, leakage levels, customer side, network side. I mentioned before the consumption profiles, how do they change through the seasons? What is the optimal meter reading frequency that we need? We are using 15 minutes data. Do we really need that? Maybe we need that only for leakage understanding, leakage identification, but we might not need this for long. Maybe we need this for just 2 weeks, 1 week, 1 month. And then we can say, well, actually, yeah, doing that, we can have 15 minutes data. But then we can revert that to daily readings, monthly readings. So, well, something that I think I didn't mention with the two technology we are using, the the Ventus Home Rider solution is a one-way system, or what they call it 1.5 way. So you can go there and reprogram the same units to now become a walk-by system, or to change them into reading frequency, but you have to go there. The Arqiva sensor system is a two-way, so you can remotely change how the meter is programmed, so the reading frequency, for example. So this, I think, it's also an important part, because we say, yeah, we need lots of data, but there are different objectives for the data we are collecting, so this is going to be evaluated. So another important thing is the impact and the requirements of IT system, because this is a lot of data coming in. So if we decide, okay, let's go for it, what will our system cope with that or not? We are going to plug in also the water efficiency people in the studies, because currently, because with this trial we are going to get so much information there, and currently, for example, they give to customers devices like new shower heads, or for the tap aerators to reduce their consumption. So with these detailed meter readings, it's going to help them to actually understand the benefits of what they are doing with that. And one of the main questions, can AMI support the targeting of mains replacement? So maybe that could be a really good solution, cost-wise. So in summary, so we are nearly completing, hopefully this week, one DMA in London is going to be completed. In Reading, one DMA should be completed by in 2 weeks, or 3 weeks, more likely. So the 5 DMAs in the end will be all completed by December, and one is going to be completed only in 2013. This is because we are using the advanced AMI in London, and because the band that Arqiva allocated that band to, because of the Olympics, to the emergency services, so we cannot use that band before the Olympics. So we are going to do that one just in 2013. So 6,500 customers involved, 2 years trial. This evaluation of these trials is going to be constant. It's going to be on a monthly basis, evaluating everything that I mentioned before. And as I also mentioned before, so the Arqiva sensor solution, this advanced AMI, is going to be the first in the UK, to be used in the UK. And obviously the cost-benefit analysis, a detailed cost-benefit analysis will be carried out to see where we can go from there. Any questions?
Thank you very much, Ricardo. Yes, are there any questions? That's a heck of a project to be thinking about. Yes.
Did you consider collaborating with the energy suppliers? Because what we see in the Netherlands, they are installing smart metering as well. And if you collaborate with them, you take away the issue that you have with data transportation, for example.
Yeah, that's one of the things, because Arqiva actually is bidding for the energy sector data communications company. Arqiva partnered with Arqiva, Detica and DT. And this solution, which is they uses the FlexNet from sensors. This is what they're proposing for the energy sector. So one of the reasons that we started this last year was because, okay, if they win the bidding, we are going to have this infrastructure in place. Why not water company to use it? So we are sort of anticipating that. And their solution that we are installing now, the meters can communicate. For example, let's say if there is no reception in an area for a meter to communicate directly with antenna, if there is an energy meter close by, it uses a relay.
Yeah.
So it's part of it.
Thank you. Yes, over there.
You mentioned the 4-hour delay where the meter companies are actually putting that in their database and then you FTP across every 4 hours. Have you not considered the direct part so you have live data?
We consider like transmitting every hour, every 2 hours, but then in the end the decision was made, well, let's do 4 hours, because we are evaluating the battery consumption as well. Is it really needed 1 hour? Well, another issue was also this data protection involved around that. So there were lots of issues, and then in the end, operations, asset management, they decide, okay, now 4 hours should be enough for us to have a water balance. We never had this anyway. So that's it. These are the reasons.
Thank you. Yes.
Has the fact that your data is shared between various locations, has that been an issue at all as far as security? I mean, you've got data at HomeRider, Arqiva, and
yes.
outside
A lot. One of the key things is, and also because of Takadu, mainly Takadu, so it's your fault, huh? Because Takadu is at least it's an Israeli company. So we have to justify, we have to check legally if they could hold the information there, but actually they are holding information in Ireland, which is fine. Although Israel is part of one of the countries, it could be, the data could be held in any European country. And Israel is also part of this because of the security they have in place. But they are holding the data there in Ireland, so it's not an issue. Arqiva and Vensis is not an issue as well either. But one thing, for example, we are not allowed to send customer details to Takadu, for example. We cannot send the address. We can send the XY coordinates. But I cannot say road A number 1. So there are lots of issues. So we have like a pile of documents that we have to prove what we are doing to protect the customer.
Good. Well, we'll take one more, yes, and then I think you.
Just one question. You're collecting quite a lot of data in either readings. Do you have any checks or verifications in place to ensure that the quality you're getting is?
Yes, one of the examples is the meter accuracy, which, for example, will be carried out at random checks at some meters, visual compared to what is being received. There are automatic checks from Takadu software, where if there are any gaps in the data, or if data is coming, a meter reading now, and then the after one is lower than the previous one, what is that? So we are going to do several automatic checks as well.
Thank you very much, Ricardo.
Thank you.